the best of my knowledge, our Psychiatry project is really the first large-scale research effort to look into whether smartphone typing would provide useful information about a person's brain health and mental health. And I want to just really thank our citizen scientists for being part of this effort.
Welcome to Collaborative Endeavors, a podcast about how scientists from different areas of research come together to tackle big health challenges, leading to better therapies and healthier communities. In our pilot episode, Dr. UL1TR002003 talked about his work in the area of depression and geriatric psychiatry, and he praised his frequent collaborator, Dr. Alex Liao. As an aside, if you haven't listened to this episode, I highly recommend you check it out to get the full picture of what this interdisciplinary team can really do. Anyway, in the spirit of partnership, we thought it was time to hear Dr. Liao's story. In this episode, Dr. Liao will talk about her work in psychiatry and how her passion for playing the piano, which you'll hear throughout the episode, led to a career in neuroscience and spawned the idea to use smartphone keyboards to predict manic episodes in bipolar disorder.
My name is Alex Liao. I am currently a professor in psychiatry and biomedical engineering. I have a hybrid appointment in the College of Medicine as well as in engineering. And I am clinically trained as an adult psychiatrist. I'm MD PhD. My PhD training was in applied mathematics. And so most of my research up until this point has been really thinking about how we can use computational models to better understand brain health. So when I was growing up, I actually wanted to be a professional pianist, classical pianist, or a mathematician. I was really fascinated by how we could potentially use mathematics to really understand the world. But as you may know, with Asian families, my parents really wanted me and my brother to be doctors. So I eventually listened to them. So when I was in medical school, I really struggled to reconcile my innate interest in mathematics. And I think I've also always been interested in reading books about general topics in neuroscience. I think when I was growing up, there was a really famous neuroscientist and neurologist. He passed away, Oliver Sacks. I read many of his books about fascinating presentation of neurological conditions in many of his patients. So I thought about potentially using mathematics to understand how, not only how the brain functions, but also what happens when the brain is not functioning. At that time, it was really hard to get into this kind of research because this multidisciplinary research really only became more and more mainstream over the last 10, 15 years. So I really struggled initially trying to combine medicine and mathematics, so to speak. I guess I was really fortunate to come across different mentors, and eventually I was able to really carve out this unique and interdisciplinary space, and this sort of the overall trajectory, how I end up where I am today.
To fully appreciate the unique interdisciplinary space in which Dr. Liao works, you need to take a step inside her mind. She painted a picture of the unconventional manner in which she views brain functionality and how her love for piano led her to examine ways to make it more resilient to aging.
So there are, again, quite a few ways of conceptualizing this relationship with playing music, especially an instrument, and neuroscience. and mathematics. So anecdotally, it has been observed many, many times that a lot of musicians, they lived a very long life, and they are still able to perform at a very high level well into their 80s or even 90s. So there is something interesting about playing an instrument. Once you master an instrument, it's like supercharging a person's brain, or configure the brain in a mode such that the brain is more resilient to aging. And so that has always been a fascinating idea for me, again, because of my personal interest in playing the piano, and also me as a neuroscientist. Again, drawing my personal experience when I play the piano, and I think about this all the time, right? When I'm playing the piano, what specific aspects of playing the piano potentially can translate to this resilience idea. So one thing I've noticed again and again is this training in coupling two different types of memory systems. There is what's called implicit versus explicit memory. Implicit memory is things that we do, but we can't necessarily describe what we mean. For example, brushing or teeth, how to use a toothbrush. That is implicit memory. We know how to hold it. We've done it so many times since childhood. We can brush our teeth. But if you really want to describe what is being done, then it becomes hard to describe. And this is the exact opposite for explicit memory. Explicit memory would be something along the lines of, say, if I were to ask you your date of birth, you can declare your date of birth. If I ask you which city were you born, you can specifically name the city. And what's interesting about playing the piano, at least for me, is this constant effort to merge these two types of fundamentally polar opposite memory functions. So the implicit part of playing the piano is, of course, muscle memory, right? I have to learn how to play these notes. But then there is a explicit part. Right? If you were to ask me, what is the first note of this music, I should be able to tell you, right? I can say the first note is A for the right hand, and after that followed by a chord with the left hand playing these notes and right hand playing these notes for this amount of beat, and then what's after that, right? So how do we actually combine those two types of memory into a cohesive and hopefully musical way? And that's fascinating, right? Because this constant training, how to really efficiently combine and learn a piece by leveraging these two types of memory and being able to learn it in a way that you could play in front of an audience under stress. It's fascinating what the brain can do. And that kind of training potentially really provides a way for the brain to become more resilient to age.
Fitness tracking devices like Fitbit and Apple Watch first hit the market around 2015. As a practicing psychiatrist and neuroscientist, Dr. Liao was fascinated by this new technology and began to ask herself, if we can make data trackers for the human body, why not the human brain?
And this is where my personal interest in playing the piano really comes into play, and no pun intended. As an amateur pianist, I'm always noticing that how well I can play the piano is linked to my concentration and my mood for that day. And so one day, as I was playing the piano, and again, this is 6 years ago, I soon realized that we should, of course, look into the keyboard of our smartphone. And to give you more context what I mean by that, imagine as I'm talking to you right now, I also start texting someone at the same time on the side. Now, because my attention is divided, I will be making a lot of typos, and I'm also going to be, my typing rhythm is going to be erratic or very variable. I joined YC in 2014, and when I first joined, because it's my dual appointment in medicine and in engineering, the Dean of Engineering, Dr. Pete Nelson, he invited me to his office on East Campus to have a coffee. And then we started chatting, and he asked me what my research interests are, since clinically I am a bipolar clinician, bipolar disorder, also known as manic depression. We started talking about bipolar disorder because it turns out the dean actually has a personal interest in bipolar disorder. And so he said he has always wanted to do something in this area. And so when we were initially designing this app, again, coming back to the keyboard idea, if you are familiar with bipolar, when a person is manic, they tend to be speaking really, really fast. And so, again, another intuition why we really think that the keyboard would work in this population is if they are talking really fast, then they should be typing really fast when they're manic. And so when we were initially designing this app, the target population was bipolar disorder, people with this condition. And so what I did was we take the first two words of the condition under the official DSM terminology, which is bipolar affective disorder. So it became a biaffect because of that. We want to get as much data in a naturalistic environment as we can. And so once you download this keyboard, you can set it to replace your standard smartphone keyboard. And then every time you are texting someone or writing an email or posting on social media, the timing of your keypress will be saved, as well as things such as how often you use the backspace, how often you have a typo. Then we essentially try to build mathematical models to unobtrusively and passively infer a person's brain function.
According to the National Institute of Mental Health, bipolar disorder affects approximately 5.7 million adult Americans, or about 2.6% of the U.S. population age 18 and older, every year. It presents equally in men and women and is found in all ages, races, ethnic groups, and social classes. Notably, bipolar symptoms can come and go, much like symptoms of depression and anxiety, though the disorder usually requires a lifetime treatment plan. Given the wide range of people affected by this condition, coupled with the fact that symptoms may fluctuate, leading some to abandon care plans, one would think that research funding in this area would be plentiful. But in fact, Dr. Liao's team struggled to secure funding in the beginning, so they sought yet another innovative solution to their problem.
Initially, we were really struggling finding research money to do this kind of creative, cutting-edge research. Intuitively, it makes a lot of sense because of the very, very multidisciplinary nature of what we were trying to do, and that's so different than traditional models of research that we were not able to convince any really conventional funding agencies to give us sort of benefit of the doubt for us to try this idea. So I was about to give up until we were so lucky to come across this Mood Challenge that was co-sponsored by Robert Wood Johnson Foundation. And this is where the idea of open science really comes into play. By leveraging smartphone, by leveraging pervasive technology, smart and connected devices, we realized that we can really scale very easily. If we can put this research app on the App Store for everyone to use, and they can directly download the app, learn about the study, consent in the study, anywhere in the U.S. within 15 minutes, then we really lower the barrier for anyone to become a participant of the study. And so we used the seed money. We were able to make this publicly available app. We put it on the Apple's App Store, and the rest is history. So that's sort of the genesis of our open science study. Fundamental principle of open science model that is different than more traditional models of research. And by traditional models of research, of course, I mean, you recruit participants into the lab, you do in-lab assessment, you put them in MRI machines, you collect data, versus open science model. In our case, is really just putting the research app on the App Store for everyone to use. Now, a second principle that really differentiates between these two different models, in my opinion, is this concept of return of value. And by that, I mean, not only we take data from our citizen scientists or open scientists, we also strive to provide feedback information on the dashboard of our app so that they can potentially learn more about their own brains. For example, they can see how many key presses they have entered for today. Just like to see how many steps it's taken for today if you wear a Fitbit. I always use every opportunity I can find to really express my gratitude towards our citizen scientists. So as of today, we have really recruited more than 2,000 citizen scientists who really trusted us with their typing data, and collectively we have obtained more than 40 million key presses from them. Again, they really trusted the research team, and so I always want to make sure I acknowledge their contribution. And to the best of my knowledge, our Bioethics project is really the first large-scale research effort to look into whether smartphone typing would provide useful information about a person's brain health and mental health. And partly thanks to our Bioethics research effort, I think the past few years there has been growing interest in looking into, as you know, with smartphone sensors, traditionally people really talk more about GPS, location, activity, heart rate, but nowadays people are starting to realize that keyboard can be another great source of information. And I think part of that is, again, a contribution from our research community. And I want to just really thank our citizen scientists for being part of this effort.
Dr. Liao shared some of the advice imparted by trusted mentors and role models that has guided her research career and helped, as she puts it, turn science fiction into science.
Every time I have the chance to introduce our Bioethics community to other researchers, either in conferences or various speaking engagements, I like to frame it as an effort to turn science fiction into science. What I have learned in this process of turning science fiction into science is that it really takes a village of open-minded people. There are quite a few folks that I have come across in recent years and that really have helped me quite a bit in sort of framing my own career trajectory. And again, coming back to this notion of turning science fiction into science. What are the necessary components or ingredients for something like this to happen? A few years ago, before COVID, I was introduced to Dr. Robert Langer, and he is a distinguished professor at MIT. Nowadays, he's probably best known because of COVID for his co-founding role of Moderna. He is one of the most cited researcher ever in history, and he's such an amazing role model for a lot of researchers in drug delivery. So after COVID, when I was able to, again, connect the dots, I realized that Dr. Langer is someone I probably should talk to for personal advice if I'm ever given the chance. So although it was really just a casual introduction at that time, I finally decided that, well, what do I have to do? Worst case scenario, he doesn't reply to my email. I took the initiative, emailed him, and he actually started communicating with me and provided me some personal guidance and advice over the past 6 months. And one thing that he mentioned, and he talked about this all the time in his talks, he always mentioned that it's important to be a good human being when we are in the middle of something, when we're in the middle of an argument or a deadline. Sometimes we lose that perspective. So he constantly talks about this importance of being a good human being, and that really resonated with me. Another concept that he discussed is this idea of, for the younger generation, make sure they learn the fundamentals, make sure they learn the basics, because the foundation is how we can use to build framework for a person to be able to achieve great things. So these are the two things that I constantly think about nowadays. If I were asked to comment on how to ensure that we have a constant flow of new generation research scientists who's going to carry a great American tradition of research, of innovation. So before Steve Jobs passed away, he gave a speech at Stanford, paraphrasing it from a memory. But he basically said, I think when we are in the middle of something, we sometimes are so caught up in this mode of trying to make sense of all the data points we're seeing right now. And sometimes that can be anxiety-provoking.
A quick note, I tracked down this speech. If you're interested, you can find the link in the show notes. Back to Dr. Liao.
I know for many, many years, I was really anxious about making sense of my own career. So he said that you can't really connect the dots looking forward. You can only connect the dots looking backward. And so you just have to have faith that in the future, when you look back, all the dots are there. And so what I have learned in this process is that as long as I keep an open mind, always be willing to acknowledge what I don't know, and always engage in a good, productive conversation with a person, even if or especially when you guys don't agree from a scientific perspective, because that's really when different ideas can come out and new ideas can emerge. And so that's how we could potentially put together a multidisciplinary team and really do amazing research. So looking back, all the dots were there. I was finally able to reconstruct why we were able to be so lucky to put together the Bioethics research team. But a few years ago, when I was starting this process, I was so afraid that this wouldn't work. And what I really appreciate for people nowadays I get to work with, and I constantly tell myself that I have to be exhibiting the same quality as what I observed in my wonderful collaborators and colleagues, is this concept of metacognition, this ability to know what you don't know, be able to sense that no matter how firm my belief is in a specific area, there's a possibility that I'm actually very wrong. And so I should always be having that open mind and be willing to talk to people in an entirely different area and see what they have to say about the specific issue. And I've noticed by doing this, you actually get into a very productive brainstorming session, so to speak, and then great ideas and great discoveries can really come from that.
Collaborative Endeavors is produced by me, Lauren Rieger, on behalf of the Center for Clinical and Translational Science, aka the CCTS, at the University of Illinois, Chicago. To learn more about BiAffect, Dr. Liao, and the research discussed in this episode, visit the links in our show notes. The CCTS is supported by the National Institutes of Health's National Center for Advancing Translational Science through their Clinical and Translational Science Award. Opinions expressed by the guest of the show are their own and do not necessarily represent the views of myself, the CCTS, or our funding agencies. You can find more episodes of Collaborative Endeavors on Apple Podcasts, Spotify, Amazon Music, and Google Podcasts. New episodes drop monthly. To learn more about how you can get involved in health research, visit ccts.uic.edu or follow us on Twitter at UICCCTS.